Let's have a go at making an equation solver in Forth. So here I'm using Forth Win. It's a version of Forth that runs on Windows. It's free in cost and it's also open source as far as I know. And we're going to look at this application today. Let's have a go at trying to create something to solve quadratic equations. What do I mean by that? Maybe in school you remember solving things of the form, say ax squared plus bx plus c. So maybe you remember solving things like that, and you have to find two answers for it, x1 and x2. Of course, we wouldn't do this in Forth notation because Forth is reverse Polish, so we're going to have something that looks a little bit more like this. Almost there. And plus. So remember, you're doing things in the order that you would actually evaluate it. So put a on the stack, then we square x times a and x squared, b and x are times together, then added to the previous, and then we add c. So let's have a go at writing this. Now in this version of Forth you can actually put a little script down here and then evaluate it later, but I might just use it to take notes as well. So to make it convenient we can have three values, so maybe we want to do something like 1 to a, 2 to b, I don't know what that would be, 1 to c, I don't know, I'm just going to come up with a random example. And then you can say x1 and then you can say x2, so I've basically just written a use case here. So to get something like that, what you'd want to do is create some values. Now values are a bit like variables, but they can be a lot more convenient to use when you're doing mathematical things. So you have to give them an initial value, so give it something sensible like 1 for a and 1 for b and maybe 0 for c. C is optional. And as you can see, we now have those. We can assign them values. In fact, let me demonstrate that to you now, so I can just run and say, for example, we want b to be 4. Oops, we just do 4 to b, and then b is 4. So very easy for the user, just like we have here. Okay, now what's the next part? Well, we need to think about how we're going to go about solving this, and the way that I think it would be good to solve this is to use the quadratic equation. I think you might know which one I'm referring to. So let me and this is where we can play around with names as well, because it's tempting to call it something like solve, right? But in the use case here, we want to just be able to type x1 and get x1. We want to type x2 and then get x2. So let's call it x1, yeah? And x1 involves solving. So quadratic equation, what is that? I could do with perhaps showing that or typing it out in reverse Polish. So I'm just gonna write it normally first. Normally, b squared minus 4ac divided by 2a. That's how I remember it. And we just want to convert that to reverse Polish. So can we do that? Yeah, we can. Some of these we have not defined yet, but we can always define them later. So minus b. So how do we get minus b? Well, we do b negate, so that means minus b This plus is going to go to the other side. This 2a is going to be multiplied first before the divide, and the rest of it looks quite reasonable. b squared 4ac. Now 4ac actually means 4 times a times c, and then we would take the square root of that, and then we see b squared minus 4ac. Okay, so we only subtract them after we've done the multiplication. So that's the really cool thing with quadratics and working them out in reverse Polish notation, because there's no confusion about the order of precedence. What do you do first? You just evaluate it from left to right. So here we basically have fourth. So yeah, there you go. And we just need to define some of these missing functions. So square, what is a square? Well, let's define that. Square is as simple as you take the number and you times it by itself. So that's the same as dupe star. Let me show you on the stack up here. So for example, if you have 2, well, 2 squared is 2 times 2. So you just duplicate the number and then multiply, and you get 4. And you know, if it was 4, you do the same thing and you get 16. So that will be how we define this, and this is just for readability basically. Strictly not needed, but it helps. Right, so we have that, and now we get onto something quite interesting. How do we calculate the square root? Now some might be tempted to use floating point notation, and the floating point square root, you can work that out. It's not as easy as what I'm going to show you, which you might actually want for many cases, which is integer square root. So what do I mean by the integer square root? Well, first of all, the result's going to be an integer. That's a whole number, not a fraction. So things like 1, 2, 3, 4, not 1.2 and 3.3 and so on. We're just going to stick to whole numbers, and it's the largest number that when squared is less than the value we're trying to find the square root of. So what does that really mean? Well, let me put some notes up here. So I square root, or we could just call it square root for the sake of this. But if we, for example, we're taking, well, it's easy. If we take the square root of 5, so in 25, we expect the result to be 5, right? But when it gets interesting is when you have something like, say you take the square root of 2. Now we know that square root of 2 is really gonna be, or let's make it a little bit kinder than that. Say it's the square root of 3. Yeah, we know that's going to be 1 point something, but integer, it has to be 1. Why does it have to be 1? Well, 1 squared is 1, but 2 squared is 4, and 4 is bigger than 3, so it's too big. The number that we get has to be such that, so let's call it n, right? So n is, or not really n, but n squared is less than or equal to the number we're finding the square root of. Right, so I'm just going to call it square. Yeah. And that square is also less than n plus 1 squared. Yeah. So that's the integer square root definition. I've written that in infix notation just to make it brief and show you clearly. And the way we can work that out is we can just try numbers. So we start from 1, and we keep going until we find a number that when squared is bigger than the number we're trying to find the square root of. So in our example before with 3, we'd try 1 times 1, and then we try 2 times 2, and 2 times 2 is too big, so we stop. And as soon as we've got the number that is too big, that number is n plus 1, we just subtract 1 and we get n, and n is our result. So let me show you what this looks like in fourth now. So I'm going to call it square root, and we probably want something like begin until. So it's going to take one argument, which is n. And here's how I would write it. I'm going to show you how to do high level code. So we're going to come up with something called try num, and we're going to go into a try num is too big. Yeah. Now we probably want to preserve the number on the stack, so we duplicate it and we try num. That way we don't lose the value that was already on the stack until we drop it, and then we can do something called found num. So that will just put the number we found on the stack, and that's it. We keep trying numbers until, oops, sorry, one small error. Try num squared. We want to square the number. As you see, we keep going until that square is too big, because we're trying to find this n plus 1 squared, and then afterwards we're basically trying to find n minus 1. Right, so now let's implement these other words. Try num, what might that look like? Well, let's say we have a variable called n, yeah? N at, and then, well, probably not that. We want to increment n first. So this is one way of doing it. 1 n plus store. So that's going to increment a variable called n, and then we just put n on the stack. Yeah. So let me stop talking about n and create it. Variable n. Yeah. It's just a name. Then when we found the num, well, that could be as simple as, so we're going to have n plus 1 at that point. We don't want n plus 1, so I guess what we do is we get n and then we subtract 1. So this is probably a good point to do a test, not necessarily of the whole system, but of the square root. So let's pick our example before 25. See what we get as square root. We get 0. So something was not quite right there. Let's see if we can figure out what it is, and maybe you can spot the mistake. I actually have this symbol the wrong way around. We're saying if the number is bigger than try num, we want try num to be bigger than that number. So let's try that again. And 25 square root is 5 exactly. And let's do it for 3. See if I've... Okay, that's quite unexpected. Ah, you see what we're not doing? We actually need to reset. We actually need to reset n afterwards. So tell you what, in found num, let's set n to 0, and whenever we initialize, remember you can run fourth code amid the definitions. So here I'm just resetting n. In fact, let's put it on the same line. 0 n store. So n will always start at 0, and then once we get to found num, we're going to reset it to 0. Do that again. It's a good test. So we get 1 this time, which is correct, and let's make sure we get 5 for 25. Perfect. So that's working. Great. So this is actually progressing really well. Now let's see if we can come up with an example. Let's work it the other way around, right? So we can actually start with something like, I don't know, x plus 2 times, let's just say x plus 3. So there's 2. Actually, let's not do it this way. I know why I'm thinking what I'm thinking. Say it's x minus 2 and x minus 3. What would you actually get? We get x squared. Do you remember how to do this? Minus 5x plus 6. So based on that, we know that b is 5 to b, and c is 6 to c, and then we say x1. And it got minus 2. Now that isn't quite what we're looking for. The answer for x being 0 isn't x equals 2, but x equals minus 2, sorry, but x equals 2. So something hasn't gone quite right in the way we've calculated this. Let's see if we can work out what that is. So we do minus b. We do b squared. We do 4 times a times c. We subtract that, so b squared minus 4ac square root plus 2 times a divide. Well, we know that we got the sign wrong, so that's a starting point. Let's try something as an experiment. Let's say we take x2. Now what's the difference with the second solution? Remember, it's plus or minus the square root, because the square root could be positive or negative. So in this case we just do a subtraction, and we can run that. Now let's just check what we get. So b was, what, an example? B was minus looking through the solution again. Yeah, b was minus 5 to b and 6 to c, and let's do again. x1 is 3 and x2 is 2. Okay, so I think what I did incorrectly last time is I probably set b to 5. So yeah, we've got 2 solutions then for the quadratic, and you can try this with other values too. But notice it's working. So there you go, we have solved a quadratic equation using fourth. I can go through more of these details in another video to show you more about the details of fourth and all the words and so on, but I just want to show you how I go about solving a problem. And as you can see, it's a fairly small amount of code. I don't know how much code that would be in C or Python. To be fair, it might not be very much, because the thing about languages like C and Python is they have good mathematical notation, so you could probably do some of these things quite easily in one line. But I think the good thing with fourth is the interactivity. It's nice to be able to just interactively test like this, and for example, to get a result, we just type x1 or x2. We don't have something called, I don't know, solve, and it takes A, B, C. You have to type out a whole line before you get something. In fourth, you just write a word or two words, and then you get your answer. So let me know how you found that.